So that's going. We're all good. Okay, welcome everyone. And I even made a little poll, which I'm going to try and use a little bit later. That's going to be fun. Okay, cool.
Peter, can you just make me host again, and then I'm going to admit all the learners.
Okay.
The learners.
Participants. And
wanted to say yesterday went quite well, hey?
yeah, I also thought so. It had such a nice, had a nice energy. Eh?
Yes.
Like also I don't often, I'm so in the moment, I kind of, but afterwards I also thought so. Like I was like, it felt a bit different.
Yes, there was interaction, which was great.
That's probably what it was, yeah.
Okay, I'm admitting the learners.
Awesome. Let me see if this is okay. Welcome everyone. Maybe you can make this a bit bigger.
Hey, Antonio, Chanel, can you guys hear us?
Welcome, everyone.
You can unmute yourself and say hello if you can. Otherwise, say or send a message on the chat just to make sure that we can hear you guys.
I'm just going to sharing settings. Hi, everyone.
Hey.
How's the day going?
You can just see.
Are we speaking to Chanel or who's this? Caleb.
Hello. Yes,
hi,
you're speaking to Caleb. How are you guys doing? You doing well?
Good. Yeah.
Go.
Hey, Antonio.
Very good.
It is great to see you guys. Where are you from in the country? Where about are you? What province? What part of the world?
Western Province.
Oh, it's a good province. A good cut. Yeah, it's a good town.
Yeah.
Just going south and you'll get to the best.
Yeah.
Welcome, Caleb. Welcome, Antonio, as well. I quickly saw your face there. Is it your guys' first time or have you been here before?
This is my first time, actually. So I'm a bit shy and nervous.
You don't have to be nervous. You get quite used to it quite quickly in that, but it takes a while just to get to know everyone's character and what their general demeanor is like. But it becomes quite normal quite quickly. You forget. Yeah. I mean, how does it feel for you? You've been doing this longer than me.
Caleb, I also still get shy and nervous sometimes, eh? So don't worry.
Oh. Okay.
Fellow, I see you have joined us. So in the interim, Antonio and Caleb, there's a question on the board. So today's lesson is focusing around probability. It's from the whole unit is about statistics and probability. And so we start with what's called a do now question. And so question number 1 is on this side. And question number 2
I can't see anything on the board. I'm not sure. Caleb, can you see anything, Antonio?
I see OneDrive, the top of OneDrive, like the top of OneDrive.
Let's see.
I don't see the.
Okay, let's see. Maybe I can try again. Any luck?
No, still like that.
Let me try another one. Like desktop 2. How about this?
Perfect.
Yes.
Can you see your guys' faces if I do that? Or okay, so rather I'll keep it on that side and then we can't. Okay. Awesome. Okay. And so you can see what's on the board now.
Yes.
Or the virtual board. Okay. So I'm going to give you guys a bit of time while we welcome everyone. But that's basically what I want you to be thinking about. So this question over here.
Yes, I can.
And that question over there. And just
Okay.
see if it sounds familiar or not. So we're trying to match these words to these events. So next year will be the year 2000. Manchester United will be one of the top 3 clubs in the Premier League next season. And we're trying to match the words, and we're trying to also then put them on the probability scale, which stretches from 0 to 1. So that's kind of what we're thinking about. And then after that, we're heading to here, just to get our brains kind of thinking in the probability way of things.
Okay.
I wonder, Ozan, is everything fine with the links and stuff? Because it seems like normally I would see quite a few more faces popping up. I don't know if you want to check that. I can't hear you again for some reason.
Sorry, I unmuted and muted myself.
Yeah.
So the learners is jumping on now.
Oh, okay. We'll just stay with the do now for the moment. I'm also going to close my door so that there's not too much sound. If somebody the dog starts barking. Okay, so as we think about these questions, can next year be the year 2000? That is an interesting question. So is that likely? Is it impossible? Is it certain? So we want to think about what word matches that. And if we know what that is, where would we put it on the probability scale? So we'll put A somewhere on here, maybe here, there. Where do you think it's going to be? Oh, I see some familiar faces. Valerie, welcome. Boitumelo. Oh, yeah, all the people. Asamakle, Tato. Welcome, everyone. It's good to have you with us. We have a few new faces as well, and we've been chatting a bit. And just while we wait, we are trying to do the 2 questions on the board. That's our do now warm-up routine that we're doing. Yeah. So while everyone is doing the do now question, do you want to give us a little hello or a little update on how your day has been? Has it been a good day? Has it been a bad day? It's Thursday, so it's almost the end of the week. When, are you in exams already, or are you starting exams next week? How's your life, basically? Just jump on and let us know. Or you can type it in the chat. Welcome, Zami. I see you have joined us. And welcome to Caleb. I see you with us. Let's have a look here. Valerie, do you feel brave enough to put your camera on just for a second so we can say hello? And who else would be? Boitumelo, I'd love to get to know a little bit about you. Every lesson, I want to get to know some of the regulars a bit better and then eventually know everyone. Let's have a look. Let's see. Okay, who's feeling brave? Or not even brave, who's just feeling okay. Ozan, anything from your side before we start the session?
From my side, just welcome to all the new students. It's so nice to have you guys, and also welcome back to all those who's already joined us before. Enjoy today's lesson and ask as many questions as you need to understand this topic, and then I'll see you guys again afterwards. Oh, and 6 o'clock, I'm not sure about you, Peter, but our load shedding sitting at 6 o'clock. So we'll make sure that we stop exactly at 6.
Perfect. Great.
Awesome. Thank you. Enjoy, Peter.
Thanks, man. Okay. So I just want to start with this first question. If you could just pop your answer in the chat. So next year will be the year 2000. What do you get for A? I see some answers are there already. Well, I think it's currently 2021, and so it's impossible. Now, impossible on the probability scale is going to be all the way down here. It's going to be 0. Now, there's actually 3 ways you could write that. You could write it as 0%. You could write it as 0.00, or you could just write it as 0. So that's all pretty much fine. Manchester United will be one of the top 3 league clubs in the Premiership League at the end of next season. Well, I mean, I'm a Man U fan, so I'm a bit biased, but I would say that, it's not impossible. I would say, how many clubs are there in the Premier League? 20. So 3 out of 20 chance. And, traditionally, Man U have done reasonably well. What did you guys think? What did you choose for B? Unlikely. Okay. So some people have said unlikely, which probably if you look at the last couple, I suppose you could look at the last 10 years as well. I'm willing to say that, look, depending on how you calculate this, it could have been unlikely or likely. Probably unlikely is fair enough. Now, unlikely is going to be kind of in this region over here. And so, if we think about what, say, 3 out of 20 is, it's going to be the same as about 1.5 out of 10 or 15%. So about a 15% probability. So over here. So it's much closer to the 0 side than the 1 side. And then the UK will win the Eurovision Song Contest. Where do you think that's going to be? Well, I suppose you would say, well, the UK is just one country in Europe. And again, there's no perfect way to do this. But I think, let's say that there's about 40 countries in Europe, and the UK is just one of them. That's pretty low. That's, you can use your calculator. You'll get 0.025, which is the same as 2.5%. So, maybe that would be down here. Okay. That is just a little introduction. And then let's look at the other one. The other one says, the probability that my train will be late tomorrow is 1 out of 10. What is the probability that it will not be late? I'd love someone to jump online and give us an answer with their voice. Oratiwe, what do you think? Or Asamakle, what do you think? What do you think if the probability that my train will be late tomorrow is 1 over 10, what's the probability it will not be late? So these are special events. They're called complementary events because only one of the two can be true. Yeah, I hear someone who is, I see Zimi has locked in an answer. Does anybody agree? Asamakle has locked in an answer. She agrees with Zimi. How did you get your answers?
Because a full probability is 1, is 10. Well, it's 1. So they said it's 1 over. So the remaining probability is 9 out of 10, which will give you 1.
So this sort of foreshadows something called a tree diagram later. But
one moment.
Basically, you're right. So these two together have to add up to 1 because they're complementary events. Only one of the two can be true. And so if you know the one is 1 over 10, then the other one has to be 1 minus 1 over 10, which is that one. Okay. So let us, I want to do a quick little Zoom survey. If I, actually, I'll do it later. So let's do a little review of what we did in the previous lesson. So just for those of you who are new and maybe need to go back and look at previous videos, we looked at, to start the series, we looked at individual data items, and we looked at where is the middle of a data set and how do we judge how spread out a data set is. Now that was a lot of lesson 1. Then lesson 2 was a lot about grouped data. How do you group data with frequency tables and putting them into sort of categorizing it? And again, how do we judge where is the middle and how spread out the data is? And then we moved on to graphically representing the data. So what are the graphs that we can use to show data? So it would be things like histograms, ogives, frequency polygons, and so on. And we also learned some new words for describing data. So that would be things like skewness. How do we tell if data is skewed or positively skewed or negatively skewed, and various things like that. So I'm just wanting to point that out so that if ever you feel like you're forgetting this stuff, you can go back to previous videos and have a look at that previous stuff or go to the app. Now, in the last lesson, we started on something called probability, and that's what I want to talk about now. So let me zoom in. So I've said here, probability is really about quantifying uncertainty by counting things. So quantifying means to give a number to. Uncertainty means we don't know the result. And how do we count things? And so today, I just want to start by trying to get a sense of the language that you guys have that you can use in the section. So in the chat now, I would like you to type any of the words that you know that go with the section. So one of the words that goes with it often is set or number of. What other words have you guys used or heard when dealing with the section of probability? I just want to see what your basic, what words have we used? I'm going to watch the chat, or if you want, you can even tell me and I'll write them down on the board. Because it's almost like we have to activate that knowledge before we can really get going. A really important word in probability is an outcome. So that's one word that you may or may not have come across. What other words can we see? So you might hear the word an event or an experiment. Oh, I see all sorts of interesting words coming up. Zimi, you on fire. So there is complement or complementary, which doesn't just mean I like something. Complementary means something specifically. Mutually exclusive. So an example of mutually exclusive events were, if you were late, you can either be late or not late. Those two events can't happen at the same time. So that's an important word. What other words? Sample space. That's probably the most important one we deal with in the section. Whenever we deal with an experiment, we talk about counting how many items there are in the sample space. Yeah, so that's a really important one. And that's where the counting comes back. What else? Exhaustive events. Yo, that's getting fancy. Yep. I see intersection. Okay, I'll talk about intersection in the next lesson, and union. So that's also an important idea. So, are things, if I say, is something in this and this? Is it in both, or is it in one of the two? Is it in this or that? So the words and or also count a lot. So knowing that and means in both and or means in one of the two or both is important. What else? Any other words? Has anybody seen any notation like, so also another word is number of. So number of items. Okay, so that's good, just to get our vocabulary going. And then what are some of the, often teachers use experiments or uncertain events, okay? They may say, I'm gonna roll a dice, because a dice, it's uncertain where it's gonna land. What are some of the other things that often come up in this section? It's not just dice, there are other things that come up. Boitumelo, what is your teacher, any other, does your teacher just use dice in this, or do they use other things? Marbles? I like that. Thank you, Zimi, that's great. Coins? Yep, that's awesome. What else? I see that, Tato, fantastic. I'd love to hear someone's voice. Antonio, what do you think? What else does your teacher use when they talk about uncertainty? Like something's going to happen, we don't know what's going to happen. Sweets? Yep, like sweets in a jar. Okay. Does anybody ever heard the word? Give me a thumbs up if you heard of this thing called a spinner. It's like, it looks a bit like, almost like a circle thing, and then it's got like, maybe like different categories. And then your teacher will say, I'm going to do some coloring in now. Your teacher might say like, it's yellow in one part. Oh, that didn't last. It's red in one part, and it's blue in another part. And then you're going to spin this thing that sits on top and see where it lands. Chances of rain. Oh yeah. You also get things like, here's a real life event. Tell me the probability. Okay. So this is important because probability, there's actually two main types of probability, and both these scenarios will illustrate them. Let me just make my pen a little bit thinner. So you get something called theoretical probability. So theoretical probability, and then you get something called experimental probability. Now, theoretical is a bit like what it sounds like. Nothing actually has to happen for the experiment to be considered. So it might be you might say something like, I'm going to throw 2 dice. I don't actually have to throw the dice. I'm just thinking theoretically about what could happen. And so, you know, what's the probability theoretically of throwing a 6? Well, there's only 1 6 out of 6 options. And so the theoretical probability is 1 out of 6. But if I am actually throwing something, if I'm actually doing something and I count how many, maybe I throw the dice a couple of times and I see how many times the 6 comes up, that would be considered experimental probability. I actually have to do something. And so today you'll see different types of questions. Normally the theoretical one gets a bit more attention, but just to realize that there are these 2 types of probabilities when we calculate, depending on the question, and they are related, which I'll talk about later. Okay, let's get going for the day. So we are going to have a go at this question. This is mainly about vocab. And it says here, list the sample space, the event, and the favorable outcome of the following probability experiments. So there's 3 examples here, and you have to name each of the things for these 3. And I'll do the first one with you. So the sample space for throw a dice and get a 6. So the sample space is going to be S. I'm going to do it like a funny bracket like this. It's just going to be 1, 2, 3, 4, 5, 6, because those are all the options that I can get on a dice. What is the event? The event is just basically, the event is just going to be that you're interested in getting is throwing a 6. So that's the event, is throwing a 6. And then the event you're interested in is getting a 6, and the favorable outcome is the throwing of a 6. So let me actually enlarge this for you to see. Okay, so that is what I was looking for on A. Can you guys try and answer B and C for me now? And this just kind of gets you used to the terminology. Oh, the activity, sorry, they use the word activity. The activity is to throw a dice. The sample space is 1 to 6. The event you are interested in getting is a 6. And then a favorable outcome is 6. Can you do B and C? Which are these two here? Okay, welcome, Marilyn. I see you've joined us. Who else is here? Okay, welcome, Caleb. So what are the, if I'm throwing a dice again, a lot of the stuff is the same, but how is the even number going to change the question? What are the favorable outcomes if I'm looking for an even number? That's the thing to consider. And if I'm tossing a coin, how is that different to tossing a dice? That's something else to consider. Okay, I'll give you a couple more seconds, and then I'm going to pop the answer up for B. Okay, so the second one, the thing I'm actually doing is still throwing a dice. The sample space is still 1 to 6, but now you're interested in getting an even number, and the favorable outcomes are not just 6, but 2, 4, and 6. And then for C, see if I can get this to go up. For C, the activity is now tossing a coin. The sample space is just heads and tails. You can write it like that, or you can just write it. Sometimes you see people write it in what's called set builder notation, where you just write down literally the outcomes. Both are correct. You're interested in getting a head, and the favorable outcome is just heads. It almost feels a bit too simple, doesn't it? But it's just the vocabulary that we use. Okay, any questions before we move on? I kind of feel like I'm going a little bit quick, but also I feel like it's just vocab. Any questions or comments?
All good,
Yeah.
all good, Peter.
Fantastic. Okay, let's go on to this question here. And then in fact, I'm going to do this with you. And then the next one you're going to do mainly independently. So a regular 6-sided fair dice is thrown. List the sample set. Now, the sample set is just going to be the 6. That's easy enough. How many elements are there in the sample set? Now, this is where notation is important. The notation we use in probability is we use an N, and then in a bracket, we'll say that the N of S is going to be 6 because there's 6 items. List the favorable outcomes. So that's A, B, C. List the favorable outcomes for getting a score of 3 or more. Now, the favorable outcomes are actually in this case going to be 3, 4, 5, and 6. So those are the favorable outcomes given the question they've asked here. How many favorable outcomes are there? We can count them. There's 1, 2, 3, 4. So there's 4 favorable outcomes. And for E, what is the probability of getting a score of 3 or more? Give your answer as a fraction in the simplest form, as a decimal, and as a percentage. Okay, now the basic formula in probability is always what is the sample set, or what are the number of all possible outcomes? In this case, there's 6 possible ones. how many of them are favorable for the question we're asking here, which is getting a score of 3 or more? Well, there are 4 items in that collection or that set. And so the probability that we're interested in this one is 4 out of 6, but that isn't expressed in its simplest form. That's going to be 2/3. Now, if I convert that into decimal, in decimal, that is just going to be 0.6 recurring or 66.6%. Okay, so that is an example probability question. And I'd like to now give you one that you can do by yourself. Are there any questions before I move on? And that was just me kind of demonstrating what I'm looking for. Okay, here is your 2 questions. So I want you to do these 2 for me. They've got a little bit harder, and I will give hints if you asked questions out loud, if there's anything you want to clarify. But in the meantime, I would like everyone to try and answer these questions. Okay, you may begin. And then I am available for hints if you ask me the right questions. Okay, so I'm sitting with all my counters in the bag. No questions so far? I'm assuming everything is going well. There are no questions for now. But please, this is the wonderful thing about being in this arrangement. We're much more flexible than you would normally be in class. And so if you do, you can type it in the chat, or you can just ask a question straight up. So the bag itself actually only has 6 items in it. The counters have different values, but it still looks to me like, the sample space consists of 6 items. And those items are just going to be these numbers up here. Okay. Once you've got your answer, which I'm assuming most of you are not too far away from, can you put it in the chat for me? So you can just do it like this. You can say BI and then give me an answer like something out of 6. So I'll do the first one. There are 6 in total. So there's 6 numbers in the bags. There's 6 possible options. I'm looking for all the odd numbers, or basically, if I want to calculate the probability that it's an odd number, I need to know which ones are odd. And so I'm going to look here to see which ones are odd. Let's see what you guys say in the chat. Okay, I see one from Caleb. Fantastic. Anybody else got an idea? I suppose I have to count how many odd ones there are. So 3 is an odd one, 7 is odd, 9 is odd, and 11 is odd. So I get 4 out of 6. or 2/3, or in another notation, 66.6%. So that would be that one. Okay, what about the second one? I want to know for the second one, what is the probability that I pick a prime number from that bag? Get rid of this, it's a bit messy. So we know the answer here. This one was 4 out of 6, or 66%. So I need to find my primes. So let me check. 3 is a prime, 4 is not a prime. 7 is a prime, 9 is not a prime. 10 is not a prime, 11 is a prime. So I agree with you, it's going to be 3 out of 6, or 50%. And a square number. What is the probability that I draw a square number? So I think 3 is not square, 4 is square, 7 is not square, 9 is square, 10 is not square, 11 is not square. So to me, if 4 is a square and 9 is a square, if I draw those numbers, that would be a good outcome, a favorable outcome. So I have a 2 in 6 chance, or another way of saying that is 1/3, or 33.3% chance of drawing a square number. Okay, awesome. Give me a thumbs up if you feel like that went okay. Give me a thumbs down if you're still feeling very shaky. Okay, because I just want to get a sense of the feel for the group. In class, normally I can read my students' faces. It's a little bit harder online. So we have to be a bit more like showing the happiness or the sadness a bit more definitely. Okay, bonus question before we go on to this next one. Is this question so if you think it is a experiment, or if you think it's a theoretical, how do I put this? I just want to know the question that we just did. If you think it's experimental probability, put thumbs up. If you think it's theoretical probability, put thumbs down. Okay, so I'll say that again. We've just done a question over here. Is this question theoretical probability? If it's experimental probability, you think it's that, give me a thumbs up. If you think it's theoretical probability, give me a thumbs down. I'm being a bit sneaky the way I'm doing this. Ah, Caleb, you are on it. So this is a theoretical probability question because I never ever actually did anything. I was just thinking in theory about what was happening. So I would need some real life data for it to be experimental probability. Okay, let us now put our attention to this question. I'll give you about 30 seconds to a minute to do it, and then I'm going to ask for answers. And then I want to hear some human voices. So, Boitumelo, can you help me out? What is the N of S for this sample space? Do you know? Who knows what the N of S for this sample space is? Or who else haven't I chatted to in a while? Can't see. Antonio, what do you think the N of S for this this group? This group has this many boys and this many girls. What does the N of S stand for, and what is it in this case? So the N stands for the number and the S stands for the sample space. So Melo, I see your emoji there. So I think if there are 18 boys and 12 girls in a class, that means together there are 30 people in the class. And so even though N of S looks all fancy, it's basically saying how many things are there in the S, the sample space, and it's going to be 30. Okay, that's all. Now, what is the probability? If I choose one random person from a class, from this class, what's the probability it's going to be a boy? And, you know, in probability language, we might even write this like, what is the probability of B, where B stands for boy and P stands for probability? Okay. So there's 30 possible choices. How many choices are going to be a boy? Well, it's going to be 18 out of 30. Perfect. Which then converts down to 3 out of 5, or you could write it, that's the simplest fraction. If you wrote it in out of 10, you can see that it would be, there's a 60% chance of it being a boy. Now, you could go and work out what the probability of it being a girl is. And look, depending on how you classify gender, but essentially it should be, assuming that you have just 2 genders, you are going to have a 40% chance of it being a girl. Okay? Because in this particular scenario, they've only given you boys and girls as people in the group. Okay, so these events would be called complementary. And so once you've worked out one, you can work out the other one by just deducting it. Okay, let us have a look at a question like this. Now, what type of question do you think this is? If you think it's experimental probability, I want you to put a thumbs up. And if you think it is theoretical probability, I want you to put a thumbs down. Let's have a little vote. Or have a look at the question. So if you think it's experimental probability, thumbs up. If you think it's theoretical probability, thumbs down. Let's see those hands. It says that in 2009, there was a census at school. Learners were asked how they usually travel to school in the morning. The following table shows the responses from 443,590 learners who live less than a kilometer from the school. That must be a very dense area. Aha. I see one thumb so far. Okay. So I think if you look at this, oh, lots of thumbs down. Okay. I think this question is more about experimental probability, because can you see that they're actually counting things here? Let's have a look. All the 3 most popular ways of getting to school. So can you see there's real data here? There's real things that we've measured in the real world. So it's not like we're saying we think maybe there are this many learners who do it. They literally went out and counted how many people there were. And so this is going to be experimental probability as opposed to theoretical. And so I'm just trying to kind of show you the difference. The one you do in your head in theory, the one you actually do by physically going out and counting things or doing things. And so just to kind of bring that difference in. Okay, I want you to do this question now, and I will help you as we go. But what are the 3 most popular ways to get to school? Somebody let me know, based on the chart. Caleb, I know you want to. Let's hear that voice. What are the 3 most popular ways of getting to school?
Walking.
Totally.
Walking is one. Car, and then scooter.
Scooter. Oh, so scooter to me looks like 290.
Oh, sorry. Taxi. Sorry.
Totally.
Yeah.
Yeah. So all you have to do is, over here are the methods of getting to school, and here is just the number of learners. And so the most popular ones would be the ones with the most things in them. So our most popular ones are basically walking. We had car, and we had taxi, which kind of gels with my sense of real life. Okay. Now, someone different. What is the N of S for this sample set? What are the number S? And let's see if there's anything in the question. Determine where S is the sample set, the number of different ways of getting to school. Any ideas? What is the number of different ways of getting to school? Well, actually, okay, this can actually be interpreted in two ways. The one way is to say you break it up into how many learners there are. And so in theory, so some of you will say, okay, well, these are the different ways they get to school. But if you think about this data set, you're counting individual people. And so the number of in this is going to be 443,590. If the way I read it, let me actually just check my answer just to make sure that because it's a little bit vague there. Okay, yeah, 443,000, yeah. So that's how many students are being surveyed in this example. Okay, last one. What is the probability that one of the learners selected at random walks to school? So I want you guys to do these last four for me. And you can put them in the chat. What's the probability a learner randomly chosen walks to school, comes to school by helicopter, comes to school by car and taxi, comes to school by car or taxi? Oh, interesting. So remember, the sample space is going to be the big number, the 443, that one. What is the probability that somebody walks to school? Seven. Question. So in all probability calculations, we always have the number of possible things at the bottom. So 443,590. Now, if we're asking the question for walks to school, isn't this category over here, let me get rid of this, isn't the walking by foot, aren't there 399,220 people who walk to school? So if we're choosing one person from this huge group, the probability of them walking to school is going to be quite big, and it's represented by this number. Now, obviously, you need a calculator. So can somebody give me a decimal version of that? What is 399,220 divided by 443,590? Oh, I see the chats. Tumelo, thank you very much. I get 0.8999 and so on. So if we're going to round off, it is going to be about 90%. So there's a 90% chance of choosing one person and asking them, how do you get to school? They walk. Okay, number two. That's great, guys. Comes to school by helicopter. Is there any option of coming to school by helicopter? Are there any students in our sample? Well, you might say there's this many students in our sample, but this amount doesn't really matter because there are no cases of someone coming to school by helicopter. And so in this case, it's going to be 0. Comes to school by car and taxi. Okay, you can debate this one about can you come into school in a car and a taxi, but I would say that they are separate categories and you can't come in both at the same time. They're mutually exclusive. If you choose a taxi, you can't come in a car. If you come in a car, you can't come in a taxi. So there's 0 people who come in both. And so even though the bottom number is still very big, 0 over anything is still 0. Okay. And then the last one, comes to school by car or taxi. Okay, this is a little bit harder. I want someone to jump in here and tell me what to do. what's the probability they come by car or taxi? Or tell me what to do when I set up this calculation. The bottom number has to stay the same because there's still only this many students that we're drawing from. But what's the number at the top going to be? What's this number going to be?
Would you add the number of people who come by car and taxi together?
That's exactly what you do. Because if you ask someone, how do you come to school? And they say car, it's considered a favorable event for the probability. If you say to them, and they say taxi, that's also considered a favorable event. So both of those events together are, favorable events. And so we have to add this one and this one. Was that Zinzi or was it, who was that? Zimmy. Zimmy, what do you get if you add those together? Do you have a calculator nearby?
Yes, I do.
Okay, what do you have there?
Let me add them. I already got the final answer, so let me just add them again.
Okay, no worries.
38,825.
Okay, and so that is going to be divided by this, which all looks a bit messy. So give me a lovely decimal to end that off.
0,087.
Okay, which if you convert to percentage is going to be 8.7% chance of, and so there's about an 8.7% chance that somebody either came by car or by taxi in this example. So this example was just trying to show you how we can give you a question which is based on real world data, and then we still use the same formulas. It's just going to be applied in kind of this type of way. Okay, we've got a little bit of time left, and I just want to introduce something called Venn diagrams. Now, a Venn diagram is basically just a way of visually representing collections of things. And so this is a very common introductory type question. I'm given two sets. The one set is over here. The other set is over here. And within the boundary of this circle are all the elements that are in A. Within the boundary are all the elements that are in B. And in the intersection, which is a word that came up earlier, are all the items that are in both. And I want you to fill out this diagram for me now at home. Where do you think each of the numbers go? And then I'm going to do some calculations with you. And then we've still got a little bit of time, but we're getting to the end of the lesson for today. So I suppose I need to know which items are in both A and B. I suppose that's pretty noticeable. I suppose that's in A and B. And that seems to be in A and B. And that seems to be in A and B. Yeah, from what I can see. Okay, so I want to know from someone out there, let's have a look. What is the items, or what are the items or item that is only in A, but not in B? Okay, what's the only item that's only in A, but not in B? Look how sneaky I'm being with the way I word that.
So,
yes.
Is it not 2?
Aha. So A, you're right. So 2 is in the set A, but it's not in the set B. So it has to be in that part of the Venn diagram. Fantastic. Who wants to tell me what item is in B, but not in A? Antonio, I see that. It is indeed 9. And you can see that 9 is here, but it's not in that. And all the other ones, the 1, the 3, the 5, and the 7 are in what we call the intersection. So I'm just going to show you some notation here. If we talk about which items are in A and B, A and B would be the items 1, 3, 5, and 7. And sometimes in fancy probability land, instead of using the and, we use the sort of unhappy face. And it's called intersection. And it's the same thing. So maybe you can say, you can think of a funny way to saying, like, you're unhappy when someone says, and you have to also do this chore, right? So like you have your chores, and then someone says, and you have to also do this, then you're unhappy. So you can see the unhappy face goes with this. All right, so that's the one way. Now, if I say which items are, okay, yeah, let's just leave it with that for now. So A and B. If I say to you, what is the number of items in A and B? So again, I'm just throwing this notation. What's the answer to that going to be? What's the N of A and B? Pop it in the chat or say it out loud if you can, because this is proper probability language here. What are the number of items that are in A and B? Well, if we look at my Venn diagram, isn't it going to be that one's in A and B? 3 is in A and B? Yes. So there are 4 items that are in A and B. Okay. If I said to you, I'm just going to use this to practice. What are the number of items in B? How many items are there in B? What would you get for that? I see some answers coming up there. Remember, N of B? Careful, because how many items are there in B? This time, only asking you about B now. Now, the set B, or the collection B, is actually in this circle. And if I count how many items are in the circle, 1, 2, 3, 4, there's 5 items. And also it makes sense when I look back to the original thing here, how many items are there in B? They're going to be 5. Okay, last question. If I am randomly drawing, put all the whole numbers from 1 to 9. Oh, I've just realized something about the question. It says put all the whole numbers from 1 to 9 inclusive in the appropriate place. There may be numbers that are not in A or B. Are there any numbers from 1 to 9 that are not in A or B? Can you find them? And where would they go? This is an important, I should have read the question more closely. Is there anything that I've left out? I see that I've left out the number 4. And the only way the number 4 can live, it's not in A and it's not in B. So it has to be outside both of them. Oh, and 6 as well. You're quite right. So using the I'm so glad we spotted that. If I wanted to say the number of items that are not, okay, actually, I'll leave nots for the next lesson. But basically, can you see there are 2 items that are not in A or B? And so that's some of the language that we will use. Okay, I think I'm going to call it a day for today, because I know the ESCOM is coming. But yeah, in the next lesson, we'll carry on with this probability, and we'll start to deal with Venn diagrams in more detail, and also what's called decision trees or tree diagrams. But there will be some homework that we recommend from the app. And Alzan, I'm going to come back to you now. If you are with us, are you still with us?
Yes, I'm with you. Thank you, Peter.
Cool. Oh, wait. Can I add? No, I'm going to do the teacher thing. You know, when your teacher goes, oh, wait, there's more homework, but I'm not going to do it. So it's over to you, Alzan, and well done, everyone. I think we did a good job today, and I hope that it was beneficial. As always, please let us know if things we can do to help you more. Okay.
Awesome, guys. I'd love to see how you guys are feeling after this lesson. Can we see some emojis or reactions?
Totally.
while you guys share your emojis, I'm going to share my screen.
Yeah. Let's have a look.
We've got one confused face.
What section or what topic are you confused about? Would you like a bit more practice on? Let's have a look. I see all sorts of emojis. Oh goodness. Let's have a look. I see tongues hanging out. Okay, anyway, over to you, Azan.
Okay, awesome. Well, it seems like you guys are feeling good. So that means no homework. No, I'm just kidding. Okay, guys, so well done. Like Peter said, you you finish with the intro on probability, if I'm correct.
Yeah,
next week we'll do the tree diagrams.
Yeah.
Awesome. So there's only 2 more lessons left on this stats and probability. So if you have any questions, make sure that you go and get your questions for these next 2 classes so that you can ask Peter anything you need to ask him. And then where can you do some activities? You know that you can go onto the Watobe app. You just click into probability. And if you scroll down, you'll get to Venn diagrams. And then there's 2 lessons that you guys can do. The first one's the introduction, and the second one is the Venn diagrams and the addition rule. Okay, so that is homework before next week, Tuesday. And then something that's very cool and very interesting that will take place tomorrow is a math study skills workshop. So basically, if you feel like you're struggling to study maths and you need some extra tools and skills on how to just make it a bit better, then hop onto the Zoom call. It's at 5 o'clock with one of our amazing mentors. She's a psychologist as well, so she can help you guys out. And one of the teachers, Marlies, if you haven't seen her yet, will also be on there. Okay, so that's it from us. Thank you so much for joining in again. Take care of yourselves, and then we'll see you again on Tuesday.
Mm-hmm. And thank you to everyone.
Yeah, thank you, Peter. Thank you,
Thank you, guys.
Peter. It was a nice session. Thank you,
Awesome.
thank you.
We're so happy to hear that. Okay, guys. Well, all the best, hey? Remember to go work hard. Continue to work hard. Bye, Caleb. Bye, Lumka. Bye, Zimi. Bye, Tumelo.
Bye, Lumka. I definitely see our regulars.
For the workshop, where can we find the Zoom link?
Very good question, Solo Fellows. So they will send out a message tomorrow, an hour before the session, and you can just hop onto that link.
Okay, thank you.
Anytime. Enjoy, hey?
Cool.
You too. Enjoy the rest of your day.
Thank you. Sorry, was that Zimi? I said Solo Fellow. Bye-bye. Take care,
Model out
guys.
the faces, because you kind of hear the voices and you recognize them, but you don't quite have that visual feedback.
Exactly.
Yeah.
Peter, thank you so much. Bye-bye.
Bye, Elza. Have a good one. Hey,
Enjoy your weekend.
Thank you. I do plan to.
Bye.